So good morning again. Let's get started on functions. So far, the programs that we have written, they contain only one function. That is, they contain only one function. That is only main function is there. And you may have noticed that the main function. So let me use a different program. Like for example, let's say. Yeah, if you take this prime.c program, it has one function, and you can see here uh, this function, every function, it has a prototype or a type signature. So what this function says, if you look at this function definition, the function starts from line 6. It starts from here, or actually the body of the function starts from line 6 and ends at line 24. And on line 5, we have the function, the first line of the function definition. And here we are mentioning that the main function, it doesn't take any arguments. No arguments. You will see no arguments or no parameters. We will see what this means is through a sequence of examples. And then you have int, this tells the return value. Okay, void means it doesn't take any arguments, it doesn't, or any parameters. And this function returns an integer. So this is the return value, the type of the return value. So let me return value type. That means this function, after execution, finally it returns an integer. So in this particular case, main is returning 0. Depending upon this, the main function is a kind of bit different in the sense main function is called by an operating system routine, and the return value from the main is examined by some invisible person sitting above main. But if we ignore main, so starting, there are other functions which we can write in our program. And it is possible for us to pass parameters to call those functions and pass parameters to those functions and examine the return values supplied by the functions that we have written. So as it is, we are calling functions. It's not like it is completely new to us. Printf is a function, scanf is a function, and these functions are supplied by the C language library. These are part of standard C library. And for printf, we are passing a string. Actually, this is not exactly a string that we pass to printf. We will see later what it is. Similarly, for scanf, we are passing two parameters. One is a string. The other is the address of an integer variable. For scanf, we are passing two parameters. And we all know what is the return value of printf. Printf returns the number of characters printed on the screen. And we are ignoring that return value, for example, on line 9. So we are ignoring the number of the return value from printf. Similarly, on line 10, scanf, it returns the number of values it successfully read from the keyboard buffer. So on line 10, and it returns, but what we are doing is we are again ignoring the return value from scanf. We have written some programs before where we look at the return value from scanf, to decide on whether we should continue or not, or something like that. So this is the code for print statements for the program, uh, for the prime numbers program. That is, yeah. So on it's very simple. On line 9, we read the input, and we have a loop here on line 12. So in the for statement, before you, what happens is, this is the first part of the for statement, which kind of, before the body of the loop gets executed, the first part gets executed, that is d will be set to 2. And then before the loop body is entered, we check this predicate. This is the second predicate or condition. If this condition is true, the loop will be executed. The body of the loop will be visited. So like, for example, if n is equal to 4, then 2 is less than or equal to 4, it is true. So you enter the loop, and you compute, like for example, if n is equal to 4, when you enter the loop for the first time, you compute 4% 2. It is equal to 0. The condition is true. So what happens? This break statement will, so this break, it doesn't have any impact on the if statement per se, but it will have an impact on the enclosing for statement. The enclosing for statement is the statement starting on 12. You come out of the for loop and you come here. So this is what happens, let's say, when n is equal to 4. But let's say if n is equal to 3, I'm just reminding you the logic, because some of you have problem with the loop. So I thought I will use this opportunity to explain it again. But on the contrary, if n is equal to 3, you say when you enter the loop for the first time, it is 3%. 2 is equal to 1. It's not equal to 0. The condition is false. So you go back and evaluate 2. But before you go back and evaluate 2, so the statement 3 here, it gets executed at the end of the for loop. That is, d gets incremented. D will go from 2 to 3. And again, the loop predicate is checked. 3 is less than, so now d is equal to 3. So d is 3 less than or equal to 3. So, so initially d is equal to 2. Yeah, so d is equal to 3. And yeah, there is some problem in this code. D is 4. D is equal to 2. Why is d 4? D starts with 2, no? So does this code works? Yeah, I think it is all right. Yeah, it's correct only. So here we check on line 18 whether, okay, so not a problem. So on line 18, we are checking if we have come out of the loop before D has hit N. Yeah. So there is a question, won't D less than or equal to N by 2 be faster for the prime number question? Yes, that is true. So instead of actually, we can, so here instead of D less than or equal to N, we can use D less than or equal to N over 2. In fact, there is a better bond that we can use. We can use something like D less than, so better thing is to use D less than or equal to square root of N. So that also you can use. Because the factor of N cannot be greater than square root of N. I'm not sure about log. Square root of N works. Yeah, not log. Okay, so I don't think you should use D less than or equal to log N. I don't think so. So this is all right. This is all right. This is also all right. So this one you think about it. So why this is very easy to argue. So this one, think about it, why this is a good valid thing to do. Why this is a valid thing to do. Anyways, so this is the prime function. This is the program for computing the prime, whether to check whether a given input number is prime or not. So now we kind of, what we do is we refactor the code. What is the question? What if we say square root of n minus 1 is not equal to 0? I don't think so, Chinmay. So there is this test. So square root of, you just check. I don't think so. This is not, yeah, I don't think this will work. Check, check. So we take this code which has the whole, everything present in the main function, everything present in the main function. So we want to do what is called as a code refactoring. So here we are going to this program. We took this code which we have written before, and we are doing a code refactoring. And I would suggest you can do some code refactoring for the programs that you have written already, code refactoring. That is, you take the code and then rehash it and kind of organize it. So here, so what did we do here? So we have, as you can see, apart from the main function, we have created one more function. We have written one more function called as isDivisor. And isDivisor function, it takes two parameters. This is your first function. It takes two parameters. The name of the first parameter is n, and its type is integer, and the name of the second parameter is d, and its type is integer. And it takes and it checks if d is a divisor of n. If that is the case, then it returns true, otherwise it returns false. And the return type of isDivisor function is bool. And here on in the refactored code, in the for loop, in the for loop, so we are checking if isDivisor nd is equal to true. If that is the case, we break and we come out. Otherwise, we continue. There are few questions. I will answer those questions in a moment. So here what happens is, let's say when the input is 4, what happens is you will get 4, n is 4, and then in the first iteration of the for loop, you will have d is equal to 2. The isDivisor function will be computed, will be called. When it gets called, what happens is control will transfer to this isDivisor function. That is, the processor executes the instructions of the isDivisor starting from the first instruction, and the value of n is equal to 4 and the value of d is equal to 2. And so if 4% 2 is equal to 0, yeah, it is the case, so it returns true. And so the return value that we get on line 23, it will be true. So you come out, you break from the for loop and you come out. So there are a few questions here. So So what is the value of n? So on line 23, we are calling is divisor function with different parameters. Like for example, if n is equal to 5, if the input number is equal to 5, throughout the loop, whenever we call is divisor, okay, I'm sorry, I'm lazy. Okay. So yeah, so the throughout so you're calling the function is divisor on line 21 multiple times. So if you look at this, this is your is divisor function. It takes two parameters. The first parameter is n, and the second parameter it is d, and it returns a Boolean value. And so this is your is divisor function. So this is divisor function, it is called, let's say if the input that we enter is 5, so this is divisor function is called multiple times. And every time it gets called, let's say it, so let's say we have entered here n as 7 from the keyboard buffer, then every time this is divisor function is called, it is called with the first parameter 7 remains the same, but the second parameter d keeps changing. So in this case, we call when in the first iteration, in the iteration where d is equal to 2, we call the is divisor function. So we call is divisor 7, 2. That is when the iteration where d is equal to 2, and when d is equal to 3, we again call it is divisor 7, 3, so on and so forth. So when we call is divisor 7, 2, so it will return false because 7% 2 is equal to 1, 7% 3. When we call here, again it returns false. Again here it returns false, so on and so forth. So there are a bunch of questions. Before I take those questions, I want to take a pause and see, is the basic idea clear? Is the basic idea clear? And those of you who have a problem, saying it is not clear, so you can send a private message to me so that I can help you. The basic idea, I know there are many suggestions are being made.
Sir, I have a doubt.
Yes.
Yes, sir. So, like in when you've written bool is divisor and you've written int n and int d in the parentheses, if you don't write it in between the brackets and you write it after you've given the curly bracket, is it the same?
What if we do?
So, like you've written is divisor and in brackets int n and int d. So
Yeah.
instead, if you write it in the next line, instead of writing it between the brackets after you've started the curly brackets, if you write it
Yeah,
int
it's the
n and
same.
int
It's the
d,
same.
and is divisor a function just like the main function?
What do you mean by main function?
Like you've written int main and then you've given the bracket, so we can similarly use bool is divisor and then give the right void in the brackets.
No, it's not like that. You are still passing parameters, right? You are only writing the parameters in the next line. That's all. But you are still parameters. If you can type in the declaration that you have in mind, then I will tell you whether it is all right or not. Okay, because I'm not able to quite see. You can just type it in, then I will say whether it makes sense or not. But Yeah, but we are passing parameters. At this point, main and is divisor, they have different type signatures.
Okay, sir. I'll just type it in the chat.
Yeah, that will be. Yes, Chinmay, what's your question?
So, like, if I understand correctly, so we've defined the is divisor function, and after that we are testing is divisor on every value less than or equal to the entered value to check whether
Yeah,
it's dividing or not.
yeah, that's true. No? That's what we are doing in the loop.
Okay.
Yeah. Anirudh, that is wrong. So that it doesn't work that way. So what you have, then N and D, they are not tied to the parameters. It's not. So the question of Anirudh, just so that you get it right. So he's suggesting why can't we have something like this? Is no, this is completely, so the function definition on line 4 does not serve your purpose at all, because you will not be able to call is divisor function on line 4 using by passing any parameters. It doesn't take any input. So you cannot use that. Any other questions? So are you all with me? What happened? Okay. So in order to understand, so you want to see if the code is working or not. It's good. So you're making a big fuss. Let's see if the code works or not. That's the question I have. So we can actually do a GDB on this. I'm not sure if my GDB here is set up all right, but let's see. I thought I will start. Here is bent on figuring out if one is a prime or not. So let's see. See, maybe here, maybe my code is could be buggy. Uh, yeah. So yeah. So it's okay. You know how to fix it. Okay. So there's the buggy code. Uh, so you can fix it. Yeah. One is not a prime. So, but we are printing. It's a bug in the code. So you should you can fix it. Okay. Good point. Ask to unmute.
Yes, sir, I have a doubt.
Yeah.
Um, right now, since you consider the case where n is equal to 1, will it even, it won't enter the for loop, right?
Yeah.
So
Okay.
will D get initialized to 2 or will it still be garbage value?
No, D will be initialized to 2. D will be initialized to 2, and the condition will be checked if 2 is less than or equal to 1, and that is a false condition. So you don't enter the loop and you come outside. So D will be initialized to 2.
Okay, sir. Thank you.
So there are some, yeah, so again, so there are few things which you are, so on line 22, so I can have line 22 instead of, we don't need the true. Uh, so this is one suggestion that is being made. So this is all right. So this works. So if it is true, then you break, otherwise you don't break. And also there is this suggestion. So instead of doing all this, can we do return n% d equal to 0? I think this may also work. Yeah. So these things, no, you should try out and see, yeah, how they work. So it should be, but this, so instead of having line 9 to line 12, you can just implement is divisor in a single line. So that is one. So, and then there is this question, our functions processed one after another. In this particular case, I will answer that question in a different class. But right now the function is divisor is defined before the function main. So when the compiler hits the function call is divisor on line 23, it knows what is divisor function is because it has hit is divisor already in the program text, and it knows it takes two parameters of type integer and it returns a Boolean value. So it knows all these things. So it is fine. But it is possible to define is divisor after main also. But we will revisit it later. So if you want it, so I think Sweta answered your question. So if you want it, just since it's a context, I will revisit it again later. But let's say if we have something like this, let's compile and see what happens. So gcc prime.c. So now you can see that there is a problem, there is an error. Because when is divisor is defined after main, and so the compiler doesn't know what this is divisor and all. So here, if we go here, but if you kind of specify what is called as a function prototype at the beginning, then everything goes all right. Are you with me on this one? If you have is divisor after the main defined, then while processing main, when the compiler looks on line 16, it doesn't know what is divisor is. In order to give it a heads up on line 4, we can just specify what is called as a function prototype. Function prototype. Can we jump from one function to another function? No, we cannot jump from one function to another function. So there is one more interesting question. So for the sake that is on scope, we will revisit the question on scope later. But let's run this program and see. Let's try to. We cannot jump from one function to another function. It's not possible. You have to make a function call. That is how you do a systematic. So gcc -g prime.c gdb a.out break main run. So next, so next, no, next. So right now, let's say I enter 4 as input. We can have function call in another function call other than main, no problem. So you want me to use TUI, but sometimes TUI doesn't look good. So that's the reason I'm not. So right now we are on line 13. We are on line 13. So we read the input. So if I say print 10, so 4 is present in a variable n. And if I say next instruction, so we on line 16, we are on line 16 now. So if I say next instruction, so 2 divides 4, so each divisor has returned false. So we entered the break statement, and since we are in the break, we came out of the for loop, and we are on line 20, and so 2 is less than 4, and so we say that it is divisible by 2. So this is how it we come out of the code. Are you with me on this one? So let's say we run it again. So we run it again, and so printf enter n, scanf. So let's say we enter 3. So when we enter 3, so E is divisor. So now if you check, the value of n is 9, the value of d is 2. So E is divisor nd, it should return false. Okay, it should return false. So since it returned false now, so we came to the end of the loop, and we are now at the beginning of the loop. Now if you look at print d, so now, yeah, so print it should be, d should be 3 now. Okay, so but 3 divides 9, so you go to the break and you come out. This is what happens. Now let's run this program again, and when we run this program again, so so again next. So let's say I enter 9, and so can we do print is divisor? So we have a good idea. So we didn't yet call is divisor nd, but there is an idea. If we can call is divisor, it is so it returns false. Good. Thank you, Abhinav. It's a good suggestion. So actually, we didn't call is divisor as a part of the program, so don't get confused. So this is a bad idea to do. Sometimes if is divisor changes the state of something, then no, you are interfering with the program. But actually, so one good thing right now is we can call is divisor using many parameters. Like for example, this is all from GDB. So like for example, print is divisor 9, 3. So it returns true. In this particular case, Varshita, it's not changing. It doesn't change the state of the is divisor. So that is the reason why we are able to do it. So here, if you see this code, we are not changing the state of any variable. So because of that, it is all right to do it. Otherwise, it's a it's a bad idea to do it. How does GDB know the data type of the defense statement? What is the defense statement here, Kishore? The type of is divisor is present because we compiled it using -g option. And let's say if you want to go and debug, you can use what is called as a step I. First of all, pi is not even present. Okay, we will come to that question later. So if I do step I, oh, it should not be step I, it should be next I. Okay, let me write it, try again. So next, 9, Control L, next. So I'm using next I to, I think next I should take us inside the is divisor function. Is it taking us? or not. Or it should be step by. So let's say this, I wanted to step inside that function, but for some reason it's not working. But what I would do is I would put a breakpoint on each divisor. So let's say now I'll run this program again. So, and then what I am doing is I will delete the breakpoint 1. Okay, so run. Yeah. So now we are in line number 31. So if you do what is called as a backtrace, what it says is, please pay attention here, guys. This is there is this something called as a backtrace. What it tells is we are calling the isDivisor function at line number 16 in the main function. So in line number 16 in the main, if you go line number 16 in main, we are calling isDivisor, and isDivisor is called with the parameters 9 and 2. That is what is being done. Are you with me here? This is an important thing, extremely important thing. This is probably the most useful thing that you may kind of, that could be useful when you are trying to debug complex programs. What is the particular sequence of function calls which led to a bug or a segmentation fault? If you want to do, you can use this. So all we are doing is, I just kept a breakpoint on the function isDivisor in GDB. So whenever the program is running and whenever the control enters isDivisor, GDB halts the program and gives the control to us. So here the input is 9, and if you see, I entered 9 as input for when the input is prompted for, and we entered the loop for the first time. So isDivisor is called with the parameters 9 and 2. And when it got called, GDB halted the execution and gave control to us. Are you with me till this point? And in order to figure this, and then we examined who is calling isDivisor and what are the parameters with which isDivisor is being called. What are the parameters with which it is being called? So if you do a backtrace will tell you that the isDivisor function is called on line number 16 of the main function, and it is called with the parameters 9 and 2. Yeah, it shows the function called stack. So I think some of you are kind of lost. Let's come out and see. So what are we doing? So GCC -g prime.c gdb a.out and tui enable. Now I'm putting a breakpoint on isDivisor. I'm putting a breakpoint on isDivisor. So isDivisor function is there on line number 31. On line number yeah. So this 31 is the first instruction of isDivisor. isDivisor. Okay. So now when I run the program, when the isDivisor function is called, since we have set a breakpoint there, GDB will halt the execution and transfer the control to us. So enter 9 is there. I am entering 9. Enter n is there. I am entering 9. So what happened is, as a part of when this isDivisor is called for the first time, with 9 and 2 as the parameters, and that is what we are seeing here. We are seeing a breakpoint. GDB says, hey, the program entered each divisor, and it entered each divisor with the parameters n is equal to 9 and d is equal to 2. And if you do BT means backtrace. We will understand what it is in detail bit later. But what we are doing here is, it says what this backtrace is saying is that each divisor is called with the parameters 9 and 2 by the function main on line number 16. So if you go and see line number 16, on line number 16, we are calling the function main is calling each divisor. Are you with me here? Is it okay? You're all doing all right? If anyone has trouble, you can send me a private message. I don't mind. And if I do continue, so now I just say continue, that is the program continues execution. So next time when the control again enters the each divisor function, the breakpoint will be, the GDB will catch that breakpoint. And so what will be the next breakpoint? What will be the parameters here? The parameters here will be n is equal to 9 and d is equal to 3. Yes, exactly. So when we do that, you see that there is a breakpoint again here, but now it is called with the parameters n is equal to 9 and d is equal to 3. All right. So again, I press, now what happens is, now if you go inside, trace inside this code, so if I do next, what happens is 9% D, that is 3, is true. So it goes to line 32. And after line 32 gets executed, you return. Okay. And then when you come here, since each divisor returned true, you enter the break statement, and the break statement takes us out of the for. Are you all with me here? This complete program trace how a function is called, and how we are tracing the function, and how backtrace and setting up the breakpoints helps us in understanding what's going on. I recommend, like these things after the lecture is over, you should take these ideas and try it out and see how things work. So that will enable you to do more interesting stuff. No, backtrace is not the opposite of next. Backtrace tells us where, so when you call a function, which function is calling you, it will tell you. No, breakpoints can be made not only on function names, you can put a breakpoint on any line number, or so you have a lot more. Yeah, like for example, as Prachak said, B33 means put a breakpoint on line number 33. So Vikram, it's not, BT is not opposite of next, not at all. What is BT telling you? It is BT is telling you which function is calling the current function. Okay, the stack, later on we'll see what stack is. It gives us a trace of which, so main called no is divisor, and is divisor called something like that. It gives us, what does BT on main does? So we'll take up that question after the class is over. Okay, so I think we should conclude this lecture here.